Good morning, y'all. My name is De'Shell Carr, and I had the amazing opportunity to map sediment variability on an artificial reef using multi-beam sonar backscatter data. So here's a little background about my project. Here, you can see this little area. That is where the actual artificial reefs are. Here are like that dot represents the dorms. It's not accurate, but that's where we lived. Um, so this area was selected for the reef due to these 4 points, which is proximity. It's about 10 kilometers from the shore, and this was chosen because we wanted to see like how the fresh water could impact the oysters. Also, it's about 2.3 to 3.5 meters deep. The resistance is great in this area because it had the maximum resistance, which means that the sediment that is placed on the seafloor would not basically like I don't know how to say it. It wouldn't like go through the seafloor and become like a part of that layer that's on the ground. And also due to the salinity. Here's the boat. Yeah, this is the boat that we use. It's called the Scully. And here's the first instrument. This is the Castaway. It measures sound speed profile. It also measures position, salinity, depth, and temperature. Here's the IMU. It basically measures the boat motion. Here is a picture of a of the antenna that measures the GNSS, which is the boat's position and heading. So it lets you know like where you're going and it gives you direction. This is the Sonar TXRX. It measures the distance and the angles to the sea floor. So it actually shows you like what is on the sea floor. And four of these things goes into the processing unit, which computes the X, Y, and Z to the actual pins on the seafloor, and that all gets uploaded into specific softwares. So one of the softwares are the bathymetric grid, and it measures X, Y, and Z coordinates. And these coordinates measures the position, which is north, east, and the Z value measures the Z values are basically the colors. So it measures the depth. And here you see these four like red images. That is actually where the artificial reefs are. So the bathymetric grid actually allows us to see where the reefs are. Next is the mosaic. This is the exact same image as this one, but it's on a grayscale and it actually shows you the sediments that's on the seafloor. Here is the dB range, and that measures the intensity. The first factor for the backscatter intensity is the seafloor slope. Here you can see that the slope is at 0. So the return intensity is -15. Angle is 0, so the slope is 0. And this is actually like an image of the multi-beam. The multi-beam has more than one beam that goes through, but for like demonstration purposes, I'm only showing this one line. Here's the slope at 20. It shows a return intensity of -10, which is a little bit more than the previous at slope 0. The angle here has changed because we had increased the angle on this side. And this slope is -10 because we decreased the angle. And the slope is -20 because we decreased the angle. And the angle is now at 10 degrees. So the return intensity is a little bit less. Next, the other factor is the frequency. So here we see 450 frequency, and it basically shows less penetration, which means that the sonar is only showing it's showing the whole seafloor, but it's not showing it as much as the other frequencies will show it. And the next we have 300 kilohertz. It measures like the middle of the sediment, so it's medium penetration. And here we have 170 kilohertz, and it's the deepest penetration, so it gives you like the most in-depth view of the seafloor. The last factor of the backscatter intensities would be the material type. So here we have soft mud with the most, no, the least backscatter intensity, and the amount of energy that is reflected back to the sonar would be less, as you can see by this arrow. And here we have sandy silt, which is another type of material. The dB here is -20, and it shows that a little bit more of the energy is reflected back to the sonar. Now here we have like, this is closer to like the bottom, and this is where like the rocks are, and it shows a intensity of -15. And since the rocks are hard, it's more energy reflected back to the sonar. So let's think about it like a ball. If you bounce a ball, the ball would come back to you faster than the ball coming back to you in the sand or the mud. So if you bounce it in the mud, it wouldn't really come up as much. But if you bounce it on rocks, then the ball would come up more. Which leads to my objective. The purpose of my experiment was to use different frequencies to identify the small sediments variabilities within the artificial reef. And here's how I did it. First, I go into my software, which is the FMGT software, and you see the mosaic here. So the colorful grid that you seen before that measured like the different depths, that was actually imported into this grid, which uses these files over here. So next we're gonna go into the different settings. In order to create a mosaic, you must apply these two corrections and also change the frequencies, because I was measuring the different variabilities, so I had to change it to different frequencies. Here I changed the pixel size, and that basically shows that the image that you will receive from the mosaic, it wouldn't be as pixely or it wouldn't be blurry. It would be like a good image that you can read. And then after all of that is done in the settings, you click mosaic and apply it. These are other graphs or grids that you can create, but that wasn't what my project was based off of, so I didn't do that. And here is an image of how it looks when the things are processing, which leads to the actual graph. First, I have a mosaic of 400 kilohertz as the frequency. Then I have one with 300 kilohertz and one with 170. As I flip through these, you can see that the images are changing. Okay, so let's pay attention to the circle. In the circle, you can actually see like the different colors. And basically, that tells you that the sediments are on the seafloor are changing. So what this means is that at each different frequencies, it's penetrating more and more, so you can see more and more of the seafloor changing. Here is the dB ranges, which measures the intensities. So up here is -22, and that is basically the artificial reefs, which you see here in like the whiter color. And since it's made out of limestone 57, the reflection back to the sonar is going to be quicker, so that's why that image is white. And here, the dB range is at -34, which is dark. So that's measuring the different sediments. And in this instance, it could be the dark mud. So using these three frequencies, I created one image, which was the RGB image or mosaic. And the different frequencies represent the different colors. Here you can see more red, which means that the 170 kilohertz was more like, mm, it was more like, I don't, hold on. I don't, oh, the, you can see like the variations better with this frequency. Here, up here, you can see a little bit of green, so therefore the 300 kilohertz frequency, um, you can see those variations better. And here you can see blue, which means that the 450 kilohertz can be seen better. And this actually like just gives us a understanding of which frequencies will allow you to show which sediments better. And that leads me to my future steps. So in the future, I would hope to create many multi-frequency images for different epochs and assess the different variabilities on the seafloor. So what this means is that um, the oyster reefs, we hope that they will actually start populating and actually growing oysters on there, and we want to see how the oysters would affect the different sediment types on the seafloor and if that would cause it to change and show different changes. Thank you to everyone who made this experience great. Any questions? Yeah. Thank you.
Very nice job. So I'm curious, uh, when you look at the sediment type and then you look at the artificial reef that is put there based on your scans, can you determine if this is going to be a successful deployment of the limestone 57? Because I know there's concern with sinking into the sediment. Is it going to stay on top where it can actually proliferate and make more oysters? Can you tell me, is the work that you're doing able to help determine good site selection and if the site selection is working? Does that make sense?
Um, I don't think my work would actually determine if the site selection is like working, but before they actually chose this site, they used PVC pipes to actually like push down on the sediment.
Mm-hmm.
And since this area gave back the most resistance, they knew that the limestone 57 wouldn't sink into the seafloor. So that did make it a great spot to put the artificial reefs.
Super helpful. And then just for the record, when you were saying you saw colors on that last slide, I thought you were crazy, just for the record.
You
But
don't
then I
have to
started
be covered.
staring, then I started staring at it and I was like, oh, there are colors in there. Okay, just so you know. Thanks.
Thank you.